Hi again. So this is for your 5.2 practice. I'm going to be doing 2 example problems with you. Again, you follow along and you'll be able to finish the rest of it for your homework and submit it through the Dropbox. So I'm going to do example number 3. It's the one with the radical in the denominator. So just like in 5.1, we're going to rewrite it so that it's not a fraction anymore. I'm going to have my 3x squared. Bring the 1 minus x cubed up to the top, so now it's a negative 1/2 power. Then you have your dx. Sorry. Excuse me. Okay. So we're not able to distribute that 3x squared into the binomial because of that exponent that's attached to the binomial. So we do have to use our u substitution. We're going to define our u to be the one that's attached to the exponent. And my derivative of that is negative 3x squared dx. So remember, we want to figure out if we're able to make that direct substitution. I have 3x squared dx here, but I have a negative 3x squared dx. So that means that we would have to actually put that negative into our substitution. So we're going to have then equaling it to the integral of a negative u to the negative 1/2 du. Because remember that we're making all of these substitutions here. Right? So that negative will have to go along with the du when you plug it in. The same thing as for the u, it's the one that's inside of the binomial. So if I color coded it, that is where the blue one is, and this is where that pink one comes from. So remember, our goal is just to get a u to a power du so that we could just integrate and take the negative out. Integrate it like usual, adding 1 to the negative 1/2, so that becomes a positive 1/2 over 1/2 plus c. Okay, so that's equals. I'm going to erase this equal sign here. That really equals there. And then we're going to be able to change the dividing by 1/2 to multiplying it by 2, so that becomes a negative 2u to the 1/2 plus c. And then our final substitution is to bring in that u in it, plus c. There you go. So your answer is going to be negative 2 times 1 minus x cubed all to the power of 1/2, and then plus c. So you'll be doing that for questions number 1 and 2. The final 3 problems in section 5.2 are the ones where you have to manipulate your du and maybe have to solve for your dx instead. So the one that I'm going to go over is the very last one. I know it looks kind of small, but you should have your printout with you. Okay. We're going to first rewrite it, bringing up that radical. So it's a cube root. So that means when we bring it to the top, instead of to the 1/2 power, is going to be to the negative 1/3 power dx. Okay. My u is going to be the x cubed plus 9x. And let's find out what our derivative is, which is 3x squared plus 9. Now we can, or with the dx. Now we have x squared plus 3 dx, which is what we want, but our derivative is 3x squared plus 9 dx. So remember that we could change this so that it looks like what we want, right? We want the x squared plus 3 dx, so we just need to divide by 3. So we're actually going to be using that x squared plus 3 dx is equal to 1/3 du. So that is going to be what I'm going to substitute in. Again, I'm just going to use the color here. I'm going to make that substitution for just that part. So we're going to rewrite it. So our rewritten part is going to be now the integral of 1/3 That's from here. We have our u to the negative 1/3, and then we have our du. So again, that 1/3 du is that entire pink part that we substituted in. And the u is just the x cubed plus the 9x part. All the rest in pencil is the work for it. Okay, so we're going to do the same process. Take out the constant first, and then apply the integral. So I'm just going to move it up here. So I have 1/3 u, adding 1 to the negative 1/3 is 2/3, divided by 2/3 plus c, so equal sign, equals 1/3 dividing by 2/3 is the same as multiplying by 3/2, u to the 2/3. And then here the 3's could cancel. Right? So then you're left with 1/2 u to the 2/3 plus c. So that's what we'll be able to substitute in to get our final integral answer. Okay, so if there's any questions, I'm going to be here for open office hours today and also on Friday at 10 a.m. So if you want to just drop in to ask any questions to help you finish up your homework, I'll be happy to help you. Have a good day.